Alright, what I want to look at is the find command, and I'm going to try to break this into two parts because find is actually a pretty good sized command. It'll do a lot of stuff. I referred to it as a pocket knife that you can whip around and fire a 50 caliber shell out of. The basics of it are pretty simple, but you can do a lot of really powerful things with it. Just a review. Looks recursively starting at where to start. You'll tell it where to start looking. Examines all the attributes of a file. The name, its size, its permissions, its ownership, anything in the inode about it. Does not look in the content of the files. Doesn't care if it's an MP3 or JPEG or whatever. Doesn't look inside the file itself. And it returns the file name complete with path name, or you can hand it off to a command and it can do a bunch of stuff. So the first thing I need to look at is the format. You say find. Easy enough. Where to start. Like if you want to search the entire file system, you could say find slash. In a lot of these examples it'll say find dot, and the dot means start in the current directory and go recursively underneath me and find stuff underneath there. Criteria is going to be a lot of stuff. That can be your name, it can be the size, permissions, whatever that it can look for. Then you're going to have, most of the time, an argument about the criteria. Like name would be your criteria, and then file name would be what I'm calling an argument. Size 1 meg, user Wilbur, so that's criteria and argument. And then finally an action, and you can leave the action off, and if you do, it just prints it to the screen, la la. But the action is where you can hand it off to some kind of command, and that's where your real power comes in. So let's take a look as we go through here. There we go. The where to start. The big thing about where to start is you want to isolate as much of the file system as you can. Now sometimes you don't have any other choice but to say slash. It's better to say something like find an Etsy or find Etsy sysconfig name. Well, it's got the name right there, but anyway, this is where it's looking. With this, it would look just in the Etsy sysconfig directory. And this one would look at Etsy, and this one is going to look at slash. And the whole thing is, here is the example I gave you. What if you had two 10 terabyte clusters mounted at Mount Data and Mount Data 2, and you said find and started at slash? It's going to look through Mount Data and Mount Data 2, since those are both beneath it. The way find works is it is by design recursive. It's going to look through everything that it can get into. So that would take forever. So you'd almost never want to do that. The analogy that comes to my mind is what was the movie? Tom Hanks comes out of the airplane, it crashes, and he's on the desert island. Castaway. That's the one. He's in there and he impresses me because he can remember how to do the area of a circle, and he's doing like pi r squared, and he's like, we were from here to here, and he comes up with, that's a search area the size of Texas. Well, and then he knew he was doomed, because this right here, this would be the size of Texas. Now, if you could do this, you could be Tom Hanks saying, that's a search area the size of Hazelwood. That'd stand a pretty good chance of finding him then, in a whole lot quicker amount of time. So, anyway, where you start is going to make a big difference in how long it takes. These lower ones, it's probably going to find stuff about as soon as you hit the enter key. Okay, moving on. The criteria. The criteria can be a lot of different things. And just to give you an example, name and iname are about the same, the only difference being the I means ignore case. It will take globbing. We've already talked about globbing. You can say star.txt and it'll find everything that ends in .txt. It'll go by user. Who is the owner of the file? Who's the group owner of the file? Is the file empty or directory? Because a lot of these are going to work on directories. All of them work on directories. The type. Is it a file? Is it a link? Is it a directory? It'll also do C and B for character and block devices. The size of a file. Find all great big files. Find all little bitty files. Permissions. It might be worth your while to look through a file system and find all the files that have write permissions in the others field, which would be odd. And then find stuff that was modified a certain amount of time ago. So these are the most basic ones. And find will actually do a lot more. If you get some spare time, look through the find man page. There's a lot to it. Putting stuff together, you have a negation for not. So if you say find starting at root junk, not user root, that would find everything that wasn't owned that was not owned by user root. If you could say not name index.html, that would find everything that was not the file name index.html. If you say find name not root, that doesn't make any sense, and that's a common mistake, and I do it myself a lot of times. You can't put the not between the criteria and the argument. A lot of this command is just going to be getting your syntax straight. So it has to be not, then your criteria, and then what you're giving your criteria. I mean, logically it makes sense in your head. Said, okay, this is not the name, but anyway, that's the way it has to work. You can do conjunctions. By default, if you just say criteria, an argument, and then space, another criteria, another argument, that's an and. And here's my example. Find, starting in root junk, user root, size 100K. It would find everything that was owned by root and had a size of 100K. If you want to do an or, and I actually found this out setting this up, but or you just put a -o between them. So a -o between this would be find anything that was owned by user root or had a size of 100K. So that gives you a lot of flexibility, and you can chain those out. You can say 4 or 5 different things, or you can do ors for different things. We won't get that complicated, but someday you may need to. Okay, criteria. The next big section of this is going to be all about criteria. Name and iname. This is where you can use globbing, and this is just going to resemble the handout I had for globbing. If you say name file.txt, it's going to want exactly that file, file.txt. See, that's what it would find. It won't find differences in capitalization. It won't find anything before it or after it. Big file.txt wouldn't be found. It's just going to be that. Okay. If you say name file star, you use your globbing rules. When you use a star or anything in this, you're probably going to need to put it in quotes just to get into a good habit. You see it would find file txt, file name, file 99, but it would not find big file because big comes before file, and it's not going to, since it's not iname, it's just name, it's not going to be insensitive to your case. Iname is insensitive to your case, so that's file, it'll find file name, and the case. But it won't find anything before it because it is at the beginning. Iname txt, that's going to be anything that ends in txt, whether it's big or small. And that's pretty much just globbing rules there. Okay, the next section is user and group. Again, these are pretty simple. If you say find, starting in root junk, user root would find everything that's owned by root. It would not find stuff that was owned by Wilbur or Orville. Users is going to find everything owned by group users, and it's not going to find those two. Now, let's jump in here and actually look at some examples. We're looking at the name. I actually made me some directories and names. CD names. And let's see what we have in here. This is basically your case stuff. So if I say find, I think I can make this bigger. There we go. If I say find, starting here, name, it's got to have a dash, name, file 1, it finds just file 1. But if I say name file star, it gets confused because it does need to be in quotes. There you go. What happens when you do this? This star resolves to all the names in your current directory, or this actually resolved to all those, and it confuses. So that's why when you use splats and question marks and stuff, you need to have it in quotes. So it actually found all the ones that started FILE, but not the big ones because it was not case insensitive. If I make it iname, it found all of them. So the name stuff is pretty straightforward. Yeah, the dot means the current directory. cd dot dot. Well, yeah. I've got one for owners. I've got some Wilbur and some Orville's in here. So if I say find, I could use dot, or I could say root junk owner. Say start there and say user Orville, and it found Orville was the owner of file 1. If I said, how about root? Root, look, it gave me owner. Why did it come up with that? Because owner, the owner of the directory itself was root, so it actually returned the directory itself. Now if I didn't want it doing directories, I'll give you a little preview here. I could do type file. Better type it out. YPE type file. There we go. Now it didn't put in the directory. And again, that is just a conjunction of there's a criteria and an argument, and a criteria and argument. They're together. There we go. Let's say find, starting, I'll just use dot dash group users. It found 4 and 5. If I said group, how about this, dash not dash group users, and there we go. So it picked up the other 3. Now to make this a little bit easier to see, you can issue these commands and say ls. Remember that action out at the very end? This is an action, and this is a real simple one, so it shouldn't be too much of a hitch in things here. That ls says just show me everything in a DILS format. So it talks about the directory, and it gives the inodes, the long listing, and S is for size. Why you'd want inodes, I don't have any idea, but it's a longer listing that will actually give us what's what in here and help us to see it a little bit better. So there was our examples for group and for users. Let's throw one more in there just for good measure. How about if we wanted find, starting right here, user not user root. There we go. 1 and 2, and they're owned by Orville. Dash ls, same command, I just added the dash ls to see that Orville and Wilbur were the owners and not root. Alright, let's keep chugging along. Go back to my screen there. There's was our name stuff. There's group and users. Empty. The empty expression doesn't take any argument, which is a little bit odd. It's just looking for stuff that doesn't have anything. So find empty would find file 1 and file 2, but and it would find under junk if it had no files in it. And under junk is a directory. Would not find file 11 and 12 because they have something in them, and it would not find a directory that had stuff in it. And then here's just an example of the negation, which just gets you the opposite of that. Let's see if we can play some more. I think I actually want back in owner. CD bump ls-lh. Yeah, I actually have some of these with some stuff in them. So if I said find, starting right here, dash empty, and I'll throw my dash ls in there so I can see it. Only one that's empty is file 4. It's the only one with that in it. Real quick, let's make a couple of directories. Make directory under spell it right, under full touch under full file. So now what I did was I made under full to where it wasn't empty. It's got a file underneath it. There we go. Under full has a file. So now if I give my same command, my find, what does it find? It found file full because it was empty, and it found under because this directory had nothing in it. And yeah, this did scare me for just a second. It found under full file. How did I create that file? With touch. We create touch, it actually creates a file with 0 bytes. So that's it right there, and it gave me the complete path name. Let's take that ls off there. That helps you to see it a little bit better. So even though it's not listing under full, it's saying there's something in that directory that is empty. So it's just finding empty files. And we could throw a negation in there too, if you spell it right. There you go. Underfull has something in it, and the rest of these do too. The negation is the opposite. Yep. Let's hop back now to my screen again. The type. You have different types of files, and just for the basics of it, cd type. I threw some different stuff in here just for good measure. I've got a regular file shown by just a dash, got a link, and I got a directory. So if I say find, starting right here, type D. I have two directories, don't I? I have myself, the directory that I'm actually in, and I have file3. Now this might throw you for a loop. I have a directory named file3. So you don't have to name a directory name just to be silly. I also could say find everything that is not a directory, which are the others. I can say find, starting right here, type F. Now it would sort of make more conceptual sense if you could say type dash, because that puts a dash in right there. But you really can't, because that would mess up your switches. Or you can do type L. And found my one link. Now this is a soft link. Hard links don't count. Hard links should look just like files to it. So file 2 points to file 1, so it knows that it's a soft link. So those are your types. And if you wanted to get fancier with it, I could say find, starting in dev, type B for block devices, and throw in a dash ls just to see that those are all block devices. Or for that matter, we could say character devices, which are just types of devices. Not important right now. There we go. Back to my thing. Size. This is where they start to get a little bit funkier, when you can start doing modifiers on numbers that you hand to your criteria. Let's take a look at this real quick. Size. You can search for exactly, if you say size 100K, notice it's a small k for one thing, which is a little weird. It will look for files that are exactly 100K. If you say size plus 100M, more than 100 megabytes, or less 1G, less than 1 gigabyte. Okay, let's look at the examples here. Find size 100K, that finds exactly 100K files. Anything else, it's not going to find. If we say dash size plus 100K, everything bigger, stuff that's smaller, it's not going to find. It's just a plus. I don't think it would find the 100K. It may. I'm bluffing. But I think it's actually greater than. We'll try that and see. We'll actually have a chance to try it here in just a second. This one, size less than 100K, and it finds the smaller stuff. And again, we'll try that. Would it find 100K itself? We'll look at that here in just a second, because I actually have a 100K file, and the stuff that it would not find, stuff that's bigger than it. Now, here's your caveat. You can't throw your plus or minus or whatever there in front of size. Dash size, that's part of your switch. So the plus or minus or whatever has to come on the argument. And that's probably my biggest problem with it. I'll forget and throw it out here every time without thinking about it. But getting the syntax straight in your head's the big thing. And hopefully this PDF will help you with your syntax. So again, let's go play. cd size. There we go. I've got 5 files, different sizes, starting off of 1K, 10K, 100K, 500K, and then 5 megabytes. So if I say find, starting right here, size 100K dash ls, it finds my one file, that is that. Now the ls command, you can't make it do -h, which I wish we could, but that's not the ls command. That is a switch that's on the find command. There's another way you could do it, but I'm not going to jump off that bridge right now. But anyway, it did find that. Find, starting right here, size 100K, boom. Notice it has to be a small k. Like I said, it's kind of weird. If I say find dot size plus 100K, now this will answer the question we had. It found 4 and 5. It did not find 100. So it truly is greater than and not greater than and equal to 100K. And similarly, we will throw in that one. We got 1 and 2. With 3 being exactly 100K, the greater than found the greater than and the less than found the less than. So if you had wanted to include that 100, you would have had to have done something like that, less than 99K, or that I did that backwards. It would be 101K to pull that third one. It would be more than 99K to pull it that way. So there's your plus and minus, and we can play with it just for another second. LH find dot size plus 1 meg, and it just found file 5. This actually is a pretty handy command if you are a system administrator and you want to know who's eating up all your space. One thing that you could do would be a find starting at slash plus dash size plus 10 megabytes. Who's taking up stuff more than 10 megabytes? And we'll watch this run, and it's finding stuff. I could have done a -ls just to see, but you can look and see what your big files are. And again, like anything else, you can say Control-C to stop it. But that's just finding my big files. And probably you could start at something huge, like G. It's not going. There's no files bigger than 10G on here. But that would be something you could put in a script as a maintenance to see who's copied big files. If you could look for stuff greater than 3 gigs or 4 gigs, you could find people that had put DVD ISOs on there. I actually kind of want to hit this anyway. The question was, could you find the users? Because you're wanting to find the culprit who's doing this. So what you would do is you would say find. You'd probably start in like home, because that's what people are going to have access to. Then your size, and then say, I'm going to say 500K, which is really small, but you would say something like 3 gigabytes or whatever. And you're saying you want it to return who the bad guy is. What you do is just throw that -ls on there, and then it would find. See, it's all about syntax. It found 1. In CentOS, it found some whopping humongous file in there. So now I could get on user CentOS and say, what is this? And then what you actually could do, and I'll show you the syntax on it, you could do an exec and say rm boop 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 boom boom. What that is saying is find all the ones at home that are greater than whatever size. When you find them, remove them. So that would be a more violent way of doing what you're talking about. If you didn't just want to know who it was, you wanted to get something. You could even work this around in some scripting and say every time you see a file, send them an email about it for every file they have. So a lot of power in the find command. All right, let's go ahead and jump back into here. Permissions. Permissions is handy. to see if somebody has changed some permissions, to see if people have the right permissions, because a normal user could do something silly like, oh, you know what, I'm just going to change my rights to 777 and just open it up to the world. So this might be something you could throw in a script too. So with permissions, again, it's always going to be dash perm. You're never going to have anything before the perm. It's all going to be after it. So if you say perm something 777, that means it's going to match it exactly. It has to be 777. If you say dash, think of it being, if it's about 777, if it's at least 77, well, at least 777, that's pretty hard, isn't it? If it was like at least 222, that would mean that there was right in every position. The other bits don't care so much, but those have to be there. And then finally, the slash, that's probably going to be your most lenient. It's going to say, well, any of them. As long as one of these match, we're cool with it. Let's go ahead and jump on into it, because I pulled this just directly from the find man page. If you said find, starting right here, permission 644, it has to be exactly 644. And it says that right there. If you say find permissions dash 644, without regard to the presence of any extra permission bits. So this would match a 777 as well. And then finally, the slash 222 searches for files which are writable by somebody. I like the way it puts it. The owner, group, anybody. As long as somebody can write to it, it's cool. It matches. A lot of times people aren't as quick with the octal as they want to be. Octal is going to be the best way to do this. But you can also specify, this says 22, which means it's writable by either the user or the group. So this is saying slash user plus writable, comma, group plus writable. And instead of a plus, they could use an equals. And that all means exactly the same thing. This one would be find at least 220. Notice this one is using slashes and this one is using the dashes. The same thing. And I'm sure you could also do the equals down here. Past this, on the find man page, it comes up with some really funky examples with some negations in it, and it's kind of cool if you really want to get into it. But let's hop out and play with this for a second. CD dump. And let's just see what kind of trouble we can get into in here. Got 9 files, and they have all different rights. If I wanted to find the one that was 777, find, starting here, PRM 777. It just finds file 1. How about if I say perm 777, remember that one? I'm bringing it back. It's a dash O for or. Perm 000 dash LS. And it found file 4, but it didn't find 777. Why not? I probably put it in there wrong. So it should have found perm 777, which was the first one, or that one. I'm not going to stop here right now. You could have done, we might be able to find another way to do it. Okay, let's go ahead and say, I'll leave the or out for right now and go back and do an autopsy on that later. It did find the 000, find starting here, perm 000. A lot of these you do have to kind of tinker with and play to see what's going on. But that's what we're doing. Perm 000. How about if we wanted the, let's say, find starting here, PERM. What's that going to do? Permissions are at least, that dash right there is going to mean at least, readable by the user and by the group. Let's throw a dash LS in there to help us figure it out. So that means both these have to be there. So there has to be a W in the user and group, which right there would, oh, it's 4, read. Sorry. Has to be an R there and there has to be an R there. And all these do have R's right there. I was thinking right. But the ones that don't have read permissions are like file 8 got left out, file 4 got left out, and yeah, file 3 should have got left out. So that makes sense. Now if we do a find, start right here, permissions, and do /440. That's going to say if either one of those is read. And let's, pooey. Let's see what it finds. Let me do that again so that we can actually see what's going on. Anything that had a read in the user or group. Now the one that should have thrown us off is this one right here. This one got picked up this time, file 3. It doesn't have read in the group, but it's got read in this other one. I don't think there are any that don't have read in the user that did have it in the group. So okay, those are your permissions, and you just kind of have to play with those and sort of get the general idea. I don't want to take up too terribly much time in it because I want to go on to time. Time, you would do MMIN. This is the first one, which is minutes. We're going to do one that's time. That's it's going to be days next, and it's the same way. If it's no modifier, it means exactly. This would find files directories that have been modified exactly 100 minutes ago. This would be less than 100 minutes ago, and this would be more than 100 minutes ago. And I do have a directory for that. CD time. I've got some, it's right now a little bit after 8 o'clock on July the 2nd. 8 o'clock being, that's 2,000 hours, right? Am I correct? Okay, so these down here are all done today, just a little while ago. So let's do find, starting right here, MMIN, modified minutes. Don't think minimum, think minutes. MMIN. Let's see if we can find one that was done 120, 2 hours ago. No, it's not going to be exact. It's going to be hard to use that exact figure. But what if we do one less than 2 hours ago? Well, file 5.txt was done, this is the latest one, July 2nd at 1900 hours. So let's do one 180. Woo, that got them all. I screwed up, but look, 1800 minutes ago. I have no idea what that is in time, but you can see all the ones that it picked up. It picked up all the ones that were the letters A, B, C, D, E, and it picked up file 5. I actually was wanting to do 180 and to do 240 and see that you're picking up more and more of them as these are an hour apart. So dash MMIN dash less than 240, and we can also turn that around to say find everything that was more than 4 hours ago. Pow. And notice that, let me do that again with a dash ls so we can see. More than 4 hours ago, you're picking up all these from back in June and the ones that were more than 4 hours ago. It worked. Okay, we can do the same thing with dates by using find. Start right here. time. That's a modified time, and we could say find everything that was less than 2 days ago. And that's finding all the ABCDs because they were just here. The 5, the ones that it didn't find were the 1, 2, 3, and 4. So June 1st, that's less than 2 days ago. Yeah, it found file 1. It shouldn't have found file 2, and it didn't. 2 or 3 or 4. And as we jack that time up, where's my mtime command? Dang it. Find, starting, let's do this, root junk time, that's where I'm at. We'll do size. Let's do what we were working on, mtime, stuff that was modified greater than 2 days ago. There we go. 3 and 4 are the only ones. So there's 3 and there's 4. Now, one thing that's kind of odd about this is it will round up and actually mean more than 3 days ago. You'll have to read the find man page about the finer points of that, so you may have to tweak it a little bit. But anyway, those are your time. The big thing with these that I found was just getting your syntax right and not trying to put your plus or minus or anything up here, but putting it actually on your variable. These are the ones for mtime. Now, one of the things, I don't know if we've covered yet or not, there are actually 3 different times on any file in the ext3 file system. You have an access time, which means the last time a file was looked at. If somebody just looked at it with the more command, it's recorded. Changed and modified sound like they mean the same thing. Changed means change the attributes of. So if you changed it, change the ownership of it, that would be recorded in the change time. Not necessarily doing anything in the file. If you do something in the file itself, if you append to the file or if you change what's in the file, whatever, that's considered modifying. But when you modify, you're most likely going to change the size of it or something, but it always changes the change time too. So anyway, you have access time, change time, modified time. One thing that's odd is the ext3 file system does not record the creation time. But anyway, you have variants of this. You have access minutes, change minutes, modify minutes, access time, change time, and modify time. Okay. The big thing on this is just scratch out your syntax on how this works. And remember, I'll shoot back to the beginning, this is one of the big things to remember. Find where to start, your criteria, and then your action. And I'm going to stop this video right here and hopefully do another one later on how to deal with this action field, because it's a little bit funky. Alrighty. Okay, here at the very end I had to vindicate myself. Find, starting right here, with all the permissions on or all the permissions off, it does find both of them. The problem is when you throw that -L on there, it just finds the one. It jumps over that for some reason. It just happens to be something with the -O. And if you really had to do it, you could just do it in 2 commands. But I had to come back and prove that I wasn't absolutely insane. But that's it.